Hello, everybody. So welcome back. As you can see, for these, I actually changed the title. So instead of like the section, like this little symbol, it actually means section. Instead of doing this, I'm actually going to put T1 because I know it can get kind of confusing because to be honest, I don't use these correctly. I think the symbol is cool, so that's why I use them. But technically it's used for section. So the most proper way is actually when I do this 7.5, section 7.5. Right? So it doesn't get confusing when I say section 7.5 or section 1, because some people might think, oh, section 1 of chapter 7. No, I actually meant section 1 of the daily packet, but to eliminate that confusion, I have changed it to topics. So maybe it'll be a little more clear. And then maybe I won't even confuse myself because sometimes I do that. So before we talk about the section 7.5 notes, I do want to do a couple of topics first to kind of get us warmed up. So the very first topic we're going to find the vertex, intercepts, and axis of symmetry from the graph of a parabola. So let me make this a little bigger because I'm going to write the notes on here. So the direction, so we're going to use the graph of the parabola to fill the table. So this is exactly like Alex. So we're just going to look at the graph. So the graph is right there. And then the first part of the question, it says, does the parabola open upward or downward? So what is upward? Upward. So first of all, that is when A is greater than 0. So that's just a concept. It opens up like a cup. Right? And then what is downward? Downward, it's when A is less than 0, and it goes down like a frown. So looking at this graph, does it go up or does it go down? So as you can see, even if you compare this, it's going to go down. So this is downward. Right? So now, the part B, it says find the intercepts. So for both the x and y intercepts, make sure to do the following. If there is more than one, separate them with commas. If there are none, select none. So that's just for you guys on Alex. I'm writing it, so it doesn't really matter. So before we talk about before we solve this, so let's recall, what are x and y intercepts? An x-intercept is when your graph crosses the x-axis. So let's go to maybe this graph. So for example, like when we did linear functions, this would be our x-intercept. This is when x is equal to 0. Right? So for example, this could be an x-intercept. Right? And then there's a bunch of other graphs. So even if we did, so we've been working on parabolas, but another one is like the cubic function. Right? Wherever the graph crosses the y-axis, wherever the graph crosses the x-axis, that is our x-intercept. So then what would our y-intercept be? So our y-intercept would be when our graph crosses the y-axis. It is when x is equal to 0. So in here, our y-intercept would have been right here or right here. It's just whenever it just intersects it. Okay, when they intersect, that's what x and y intercepts are. So let's look at our example now. Then we're going to look at the x-intercepts. So along this graph, so usually when you find the x-intercept and you're given a graph, what I normally do is I go about this x-axis, like I put my mouse or my finger, whichever, and I'm going to see, is there ever do I ever cross the graph? So for example, let me show you what I mean. Going over to the left. So for example, if our graph, that's big, it is fine. Okay, so if our graph looks like this, what I'm going to do is I'm going to take this mouse and I'm going to go and I'm going to see if my mouse ever crosses our graph. And it does. It crosses it right here, and I keep going, and it crosses it right here. And wherever whatever y value or whatever x value it crosses, that is the x-intercept, right? So this line is ginormous, so I can't tell the x-intercept or the x-intercept to be in here, but I hope you guys understand what I mean. All right, so now let's go back to our example. So I'm going to drag my mouse across this, right? But this never meets with our function. So as you can see, our function is down here. So our function never hits the x-intercept. So because of that, there is none. Okay. So same thing with the y-intercept. What I do, so instead of going across the x-intercept, now I'm going across the y, and I'm going to see wherever my function crosses the y-axis, right? So we're going to do it here in the example. So let's go, and then it's kind of small, so maybe I can just expand it a little bit so it's a little more clear. Okay, but when we go, so you can go up to down, down to up, it doesn't matter. All right, but if I go and then I finally cross, so I meet this graph because it's blue, so it meets at this y, at the y-intercept, when at the point 0, -7. All right, so y-intercept, they just usually just put the number, so it's -7. But no, this is so for concept. So if I ever say the y-intercept is -7, and I ask you what the point is, the point when the y-intercept is -7 is 0, -7. Right? So the main concept here is y-intercept. You know that is when x is equal to 0, and then for x-intercept, I know there's none here, but it could be like a0. The x-intercept is when y is 0. Right? So now, what is the equation for the axis of symmetry? So honestly, I think it is kind of weird that they're asking for the axis of symmetry first, because normally we find the vertex first. So let's go ahead and do D first, right? If you want to do C, when you do Alice, that is perfectly fine, but I'm going to find the vertex. So what is the vertex? The vertex is either the minimum or the maximum value of your function, right? So it's the point where your graph changes. So for example, at this point, let me change a different color. Oops. Right? The vertex is when, so your graph, so for example, this graph is increasing. After it hits this vertex, our graph is decreasing. Right? So it's kind of where where the concavity changes. Or it just flips. Not flips, but it just changes, right? So instead of it constantly increasing, once it hits its vertex, it's going to decrease. Or if it goes up like a cup, our function is decreasing until it hits its vertex, and then it starts to increase. All right? So when I look at this, right? So maybe let's go a little closer. Right? So when I'm looking, so what is the vertex? I notice the vertex is right here. So it's a little more horizontal, so this is still a U shape, but it does get a little flat at this area. Right? So our vertex in this case would be 3, -3. Right? So our vertex is 3. So, okay, I'm not going to write it there. It's going to be 3, -3. Right? And so what is the axis of symmetry? The axis of symmetry is, the axis of symmetry is the axis where if I fold it along that line, then my function is symmetric. Right? So each side looks the exact same. So I know this is my vertex right here. So my axis of symmetry, so the vertex is also where your axis of symmetry is, right? So, but as you can see, the axis of symmetry, for a quadratic function, for a parabola, it is always vertical. Okay, so this is going back to when you graph like y equals something or x equals something. Which graph gives you a vertical line? And if you said x equals a number, then you are correct. Right? So, but now that we know our vertex, I don't need to guess. This is x equals 3. So it's just the x value of our vertex. Right? And this is how you solve for topic 1.